This is the video tutorial for today's lead code problem of the day 2435, which is paths in matrix whose sum is divisible by k. So let's read through the question first. You're given a zero indexed m cross an integer matrix grid and an integer k. You're currently at position 0 comma 0 and you want to reach the position m minus 1 to n minus 1, moving only down and right. Return the number of paths where the sum of elements on the path is divisible by k. Since the answer may be very large, return it modulo 10 is to the power 9 plus 7. This is marked as a hard problem, but I don't think this is really a hard problem. This is one of the easiest hard problem I've seen. This should be a medium problem because of the constraints. So if we look at the constraint, the first constraint on m and n is that both of them are less than 5 into 10 raised to the power 4, and that also the product of m into n is less than 5 into 10 raised to the power 4, and that k is less than equal to 50. So why this constraint is important here is, see, if n cross m, okay, one sec, if n cross m is less than 5 into 10 is to the 4 and k is also less than 50, so what is m into n, or rather n m k? So n m k is basically 50 into this thing, right? So that is 250 into 10 is to the 4, which is nothing but 2.5 into 10 is to the 6. So this is very less than 10 is to the power 8. If you didn't know, 10 is to the power 8 is the like constraint that we take on the number of operations that we can do. So if this is very less than this thing, that means we can do n m k number of operations to solve this question. Okay, but still, how do you solve this question? Is it it is a basically a DP question. I will show you the recursive solution for this DP question. If you want to have the iterative solution also, you should try to implement it after watching through the recursive solution. Try to implement it. I will also leave my iterative code in the description below. Okay, so let's see how you can do this. So let's take the first example and let's do a brute force of this and see what are the paths. So here, this is the graph, this is the matrix, and what is k here is 3. Okay, so k is 3. Now we can see what are the paths starting from 0. So basically what we need is a path starting from 0. Okay, let me use this. So starting from 0, ending here, going right and down, and the sum is divisible by 3. Okay, so we can see this path: 5 plus 2 plus 4 plus 5 plus 2, so that is 7 plus 4 11, 11 plus 5 is 16, 16 plus 2 is 18, so 18 is divisible by 3 because 18 mod 3 is 0. Okay, now if we go over this path, so now for that is 5 plus 3 8, 8 plus 0 is 0, 0 8 plus 0 is 8, 8 plus 5 is 13, 13 plus 2 is 15, and again 15 mod 3 is 0. So this path and this path, so the number of paths that we have are 2. This is 15. So number of paths is 2, that is the answer. Okay, how do you do this? See, if you do a simple DFS here, one sec, if you do a simple DFS here, right? So let's say you are at row R, you are at row C, and you till now you have gotten a sum S, right? So let's say we are at this cell, starting from this cell. So we are at row 0, comma column 1, and sum is 7, right? So RCS. Now from this state we can go to R plus 1 CS, that S plus let's say grid IJ. So let's say grid IJ, right? And we can go, this is basically going down. Now we can also go right, so that would be the row would remain same. C plus 1 S plus grid I j. Okay, so right, this makes sense. The only problem here is so now so what would be the all the possible number of states? So number of states is R. So R could be as big as n into m, right? M is c. This c could be from 0 to m minus 1, so n into m into sum. Now this sum can be very very large, right? This sum can be very large because this is just the summation of the values that are possible in the grid. Now this possible number of values in the grid is the constraint of 100. So 100 into around 5 into 10 to the power 4. So this is very large. But do we need the whole sum? We do not need the whole sum because we are not doing anything on the sum. we are only interested in sum mod k, right? We are only interested in sum mod k because we only need to see if this value is divisible by 0. So what I mean here is, at this we'll not keep 7, we'll keep only 7 mod 3. 7 mod 3 is 1. So now in what so this would be n into m, and this will keep only mod k. So if it is in the mod k, the number of remainders are 0 to k minus 1. So n into m into k, so the number of states are n into m into k, n m k, right? So if number of states are nmk, and the number of what is the transition time here? So from this state, how much time did you take to go to the other state? You took over one time, right? You didn't do anything. So always remember, time complexity in recursive dp is basically a transition time into number of states. So transition time is 1 into nmk. So this is just nmk, and we saw nmk is fine. Right? So all you need to do is just to do a DFS traversal here. Okay. Again, we'll use another color here. So all you need to do is do a DFS traversal, like this traversal. Yeah. Okay. One sec. This traversal. All these traversal. Now, when you are at this state, you have a base case that if r is double equals to n minus 1 and m is double equals to m and c is double equals to m minus 1. Now you will check that if your sum is equal to 0. Again, not the whole sum, the sum under mod k. So this you will check, and yeah, this would be our base case. Then at any other state, you will go up, you will go down, you will go down. As we saw in that transition, you will go right. And the answer, right plus down, you will just return answer. So let me show you the recursive implementation here. Okay, one second. Let me get that summations. This one and copy to editor. Yeah. So what I did here is basically I created some global variables. So n is basically the number of rows, m is number of columns, mod is 1e9 plus 7, because we do not need the whole answer. The answer could be very large, like there could be a large amount of paths, but we, as the question said here also, that we do not need all the paths, we only need paths under modulo 1e9 plus 7, and this k is basically under mod k, right? So I created a global matrix rather than passing it into the recursive function, and this DP array, which would be of n into m into k size, because we saw number of states here. See, the size of DP is always the number of changing parameters. Here, the number of changing parameters is 3. R can change, C can change, and this sum I'm saying as mod k, that is sum under mod k. Okay. So I instantiated all my global variables. Then I created this DP of size n into m into k, and then I run my recur function, and in this recur function, what we are doing is I've created this new mod k. So new mod k would be what? The old mod k plus the value plus the value that we are currently on. So that is basically, see, if you have come at this state with a sum of sum s, what would be your new sum? New sum would be sum plus grid ij mod k, right? New sum is basically sum plus the value that you are currently on. That is what we are doing here. Just I've changed the name of it. So now, if you, as I said, if you are at the base case that you are at the bottommost cell, you just need to check, is this nk equals to 0? If it is not, then will if it is not equal to 0, then this is an invalid path. The sum is not divisible by k, so we'll return 0. If it is, we'll return 1. We have find one valuable path. Now, this is just a memorization of the solution. So if you don't know what memorization is, that basically we have created a dp array, and then in this dp array, because see, this recur function could get called for 2 comma 3 with mod k of 5, then it can again get called with 2 comma 3 with a mod k of 5. If it is getting called 2 comma 3 5, then the answer would remain same. So we do not need to recalculate it. We'll just store it in this DP. This is a very high overview of what DP is, but yeah, we'll just store it in that DP and we'll just return that answer. We do not need to recalculate the same thing again and again. So int ans. So I've created this int answer equals to 0. I basically add the down answer, I add the right answer, and just return this answer and also store it in the DPR. So hopefully this makes sense. If I can submit this and it should work. La, 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 la. Yeah. So yeah, thanks for watching. I will also leave the implementation in iterative DP in the description. So you should try to implement it using iterative DP if you were able to understand this code. Thanks for watching. Bye bye.